Hi children, this is your physical science facilitator SS from Commando Group of Schools. Welcome to the online classes. Students, in the last session we learned something about refraction, what happened when the light travels from rarer to denser, denser to rarer, and what is refractive index and what is relative refractive index, and one important concept regarding to 1 mark. When the light ray does not deviate or does not bend when it passes from one medium to another medium, that is also we learnt. Okay, two cases now. When light passes perpendicular, of course it is between rarer and denser, perpendicular to the interface, or if these two, rarer and denser, both are having the same refractive index, then also the light does not bend. Two cases. Of course, some people are going to say like this also. It is called interface, no? When the light passes like this along with the interface, then there is also no deviation or no bend. Some people are going to say, but you have to remember the question. What is the question? When light passes from one medium to another medium, not grace with interface. Okay. So when moving from one medium to another medium, it does not bend in two cases. When it passes perpendicular to the interface, or when the two media is having the same refractive index. Clear? Yes. Now, very important activity in this chapter is about Snell's law. Okay, Snell's law. Very important concept and very easy concept also. But further class also, in coming upgrading class also, Snell's law is going to be applicable in different cases. So before going to know this, you should know some trigonometric functions. Trigonometric functions. You know what? Sin theta, of course, cos theta, tan theta, of course. Totally three trigonometric functions and three reciprocals of them. We call it as a cosines. Okay, so sin is about opposite side by hypotenuse. Cos is about adjacent side by hypotenuse. Tan theta is the ratio of sin by cos. Hypotenuse will cancel. Opposite side by adjacent side. Okay, these three relations, just remember those three relations. Okay, we are going to apply those things also. Okay, right. Now, what is Snell's law? First of all, Snell's law states that the ratio of sine of the angle of incidence and sine of the angle of refraction remains constant for a given pair of media. Don't forget, the media should not change. Like this, one medium, rarer medium and denser medium. It is a pair of media, rarer and denser. We should not change the media. Okay, so when like this, one incident ray, it is about one incident ray. From this point of incidence, what you will construct from normal. Now it is going from rarer to denser. Now what happened? It will move towards the normal. If I am going to change the angle, here some angle of incidence is there. Now I am going to change that angle. Okay, so maybe I am increasing or maybe decreasing, like this. Again, it is a point of incidence. From this point of incidence, from one normal, it is about angle of incidence, and again it is going to bend towards the normal. It is about the refracted ray. Okay, so it is about angle of incidence. It is angle of refraction. It is also angle of refraction. So here, what Mr. Snell said, the sine of incidence, sine is a trigonometric function. Sine of I stands for angle of incidence. Ratio means by, with whom? Sine of angle of incidence with whom? Sine of angle of refraction. It's a sine of angle of refraction. It always remains constant. It should be a constant. Okay, so that is the Snell's law. But you know one thing, this constant will give us refractive index. What will give us? Refractive index. Of whom? Second medium with respect to first medium. Second medium with respect to first medium. Generally we call it as N2, 1 means 2, 1. Second medium with respect to first medium. Don't forget, clearly in the definition it is given for a given pair of media. So we should not change the media. As long as the media remains constant, whatever the incident angle you are going to be considered and whatever the refracted angle you are going to attain, that ratio should remain constant. That is Snell's law. Okay, so Snell's law is going to say that it is a ratio. Ratio is by of whom? Ratio of sine of incidence, sine of refraction. What about the ratio? It always remains constant, and that constant is also going to be equal to refractive index of whom? Second medium with respect to first medium. Already I explained about refractive index of glass with respect to air. Glass with respect to air. So don't forget, when you are going to say about the refractive index, two media should be there. With respect to one medium, another medium we are going to be attaining. Okay, so refractive index means we have to be consider both the media. Okay, we need both media. Now, let us see about this Snell's law definition. You know what is Snell's law definition? The ratio of sine of the angle of incidence and the sine of the angle of refraction is constant when for a given pair of media. Okay, sometimes the question may be given like this: define Snell's law and explain the activity. At that time, you have to define the definition. Okay, Snell's law also you have to define, then you have to go for the aim, materials required, and of course the remainder. Have understood what is Snell's law? Snell's law is going to say that the ratio of whom? Angle of incidence of sine and angle of incidence of refraction. Of course, sines. It will remain constant and will gives us refractive index of second medium with respect to first medium. Right. For this, what is that activity and how we have to do this one? Let us see. So here, question will be given like that. Explain the Snell's law with an activity, or how can you say that sin A by sin R is a constant, or one more thing like that, N1 sin A is equal to N2 sin R. Okay, for all this, the question with respect to question, we have to change our A. Okay, so for example, Snell's law is given. So what is that? To prove. Okay, an activity to prove Snell's law. An activity to prove the Snell's law. Or if they given like this, to prove what? To prove sin I by sin R is a constant. Based on the question, we have to change our A. Based on the question, we have to change the A. Okay, A is over to prove the Snell's law. What are the materials we require for that one? Okay, for that, first of all, we should take one. Like this, a thick cardboard and one white paper, and then protractor, scale, and of course pencil, and semicircular glass lamp, and laser light. These are our requirements. Okay, understood what are the materials required? Thin cardboard, paper, or maybe chart, and scale, pencil, protractor, semicircular glass lamp, and a laser light. These are our materials required. With that materials, what we have to do? Okay, so what are the materials required now? Okay, white chart, cardboard. Of course, pressing pins also we need. Pressing pins. Then semicircular glass lamp. Then scale, protractor, pencil. Okay. And laser light. These are our requirements. Next, procedure. Let us see what is the procedure. First, take a cardboard like this. Take a thick cardboard. Now take white chalk. Take the white chalk and fix on the cardboard with the help of pressing pins. Okay. Now, on the surface of this, we have the two perpendicular lines. Have to two perpendicular lines like this. Okay, so let us guess that it may be M and M, or it may be M and M. Now, with the help of protractor, we have to divide into equal parts like this. Some angles are there, now we have to measure the angle and have to divide this into equal. Okay. Now, like this, I am going to draw. First, you have to measure the angles like this. Now, you have to measure the particular angles. And of course, this side also. But actually, no need to draw this side because we are going to use only two directions only. No? Like this, in every side, we have to use angles. Now, keep the glass slab which is exactly coinciding with this. So, like this. It is the horizontal element now. So, we have to keep this one exactly coinciding with this one. And the midpoint should be vertical, 90 degrees. Okay? Now, we arrange the glass slab like this. Now, from here, maybe consider 15 degrees, 20 degrees, 30 degrees as usual, as you like. Okay, so from this side of the glass slab, we have to present laser light. Now, here, laser light maybe. From this side, we have to use laser light. It is the ray which is passing, incident ray. For this incident ray, what happened? It is moving from here to here now. So, ray to denser. Now it is coming from denser to rarer now. It will move like this and it may give some magenta ray. Now extend this ray and have to identify in which angle it is going to be emerged. That angle you have to be measured. It is about from this one angle of incidence and about this angle of refraction. So angle of incidence is there, angle of refraction is there. When you apply sine for this, sine of I, sine of R. For each and everything, we have to be noting a table. For that, how to construct one table. Serial number, angle of incidence, angle of refraction, next sine of angle of incidence, and sine of angle of refraction, and then sine I by sine R. It is the table what we require. We know maybe for case 1 we take 15 degrees. For that some angle will come. Apply sine for incidence, apply sine for refraction. And how to find sin I by sin R. Sin I by sin R. It may give some x. For second case also we are going to take here A, B. It may use for A, maybe E, and here it may be G. For here it may be C and it may be D. For here, whatever the angle you are going to attain, here you will use x, x, x like this. From this what you notice? The ratio of sin I and sin R is always remains constant. What is our observation? What is the observation now? I observe that from the above activity I observe that the sin I by sin R will always remains constant. Conclusion. What is conclusion? Snell's law states that the ratio of sin I by sin I is always remains constant. Okay, so that what you can say sin I, here I am going to conclude that sin I by sin R is a constant. That is our conclusion. Okay children, let us see once again here. This is about the procedure now. How to divide into two with respect to what you call 90 degrees. Okay, right angles. So 1, 2, 3, 4, 4 parts will come. With the help of protractor we have to measure the angles and exactly coincide with the glass slab to the horizontal line about mm. Okay, now this 90 degrees at the midpoint, when you project with an angle of incidence with respect to this one, of course. Now already you know that always you have to measure the angles, maybe the incident or maybe the refraction from the normal. Okay, then there is no confusion. Now, when you have to do that activity, I you are going to take and R is coming. For different I values and different R values, the ratio of sin I and sin R will remain constant. That is our observation. What is observation? From the above activity, the last column of the table remains constant. Then conclusion, from the above activity, I conclude that Snell's law has proved that the sin I by sin R is a constant. Okay. So here you should understand one thing. Sin I by sin R. You know, refractive index is the reciprocal of the velocity. Angle of incidence, reciprocal. No? So here also you will get as n2 by n1. Refractive index of second medium, refractive index of second medium with respect to first medium. Sin I by sin R is a constant. It is also ratio of n2 by n1. So sin I by sin R is equal to n2 by n1. When you cross multiply this, what you will get? n1 sin I is equal to n2 sin R. It is also important for us. Okay? Note. Under note you may write this one. Okay? Right. Now let us see that activity how we have to perform. Okay? Right. Let us see. Okay, children. Now we are at the activity now. Right? So things required: a cardboard, paper, pencil, scale, protractor, glass slab, pins and laser light. Now with the help of pressing pins, we have to fix this white paper with the help of pressing pins. Okay. Right. With the help of pressing pins, the paper has fixed. Now like this. With the help of scale and pencil, divided it into 4 equal parts by drawing horizontal lines. Okay, like this one called M and M. And take one more vertical line. So like this, and represent as N and N. Now with the help of protractor, we have to divide. Of course, this N should coincide with 90 degrees, and this M should coincide with this 0, 0. Now with the help of this, I am going to represent each and every 10 degree. Each and every 10 degree. So like this, 10, 20. I am measuring from here. Why? Because our angle of incidence or maybe the refraction are going to measure from the normal. Okay. So if you need this side also, you can measure, and you make if you want to take a big one also, you can measure. You can take like this with equal divisions. If you want to take a huge one, but the glass slab is not so big, no. Okay, so that I am going to take this, and this side also. And this side also we have to take exactly the 0, 0 should coincide with this N, and 90 degree coincide with N. It's about M is 0, 0, N is 90. From here also 10, 20. From here I am going to measure because it is the normal. From the normal. Okay, so don't get confused. Here also for each and every 10 degrees I am going to measure like this. Now take the glass slab, take a clean glass slab and keep on the surface of it exactly coinciding with the M line. Okay, so like this. Okay, so here you may observe the angles. Now with the help of laser light, I am going to project an angle maybe with different angles. Maybe here at 40 degrees I am going to coincide this with 40 degrees. Now like this 40 degrees. You may see there what is that angle. Here it is 10, 20, 30, 40. I am projecting this incident ray with 40 degrees. But you may see there, what is that angle of refraction? It is about angle of incidence, no?
30.
It is about angle of incidence. And there you may see, what is that angle of refraction? It's about, it's not 40, it's around 30, around of 30. Means angle of incidence is 40, angle of refraction is around 30. When you find the ratio, about sin I by sin R, about sin 40 I took here, that is around sin 30, around 30. It may give some value. Now, in second case, I am going to take another angle. I am going to project with 20 degrees. There, it's about 15. Yes, it's in between of 10 and 20. So here, when I am going to use sine 20 as the incidence, it is giving about sine 15 around sine like that. So it will also give some value. I am just giving a reference. Okay, just reference, because not accurate, we are not going to measure accurate this angle now. When you find these ratios, maybe sine 40 by sine 30 or sine 20 by sine 15, it may be some x value. Certainly it will also x. Or you may take another angle, about 60 degrees. I am going to take 60 degrees. For 60, what is that? For 60, it is about 37 like that it is coming. So for sine 60, it is coming about sine 37 like that. It will also give x value. So from this, what you understood, the ratio of sin I by sin R, even though the I and R are different, for different R values, the ratio of sin I and sin R remains constant. Okay, so what is that refractive index? The constant is nothing but refractive index of whom? Second medium with respect to first medium. Refractive index of second medium with respect to first medium. Generally we call it as N21, means second medium with respect to first one. Or we can write like this, no? Sin I by sin R is equal to N2 by N1, because refractive index of second medium with respect to refractive index of first medium. By the cross multiplication, what you will get here? N1 sin I is equal to N2 sin R. It is the Snell's law. Okay, so it is proved. Okay, have understood, children? It's about the activity. Sometimes the question may be asked like this. A student Sudhir wants to do an activity and the apparatus is having maybe like this. They are going to ask a glass slab, protractor, scale, laser light and pencil. What the activity he is going to do and what is the activity he is going to perform, or what he wants to prove. What he wants to prove? Snell's law. So like that, with respect to question, we should be able to answer. Okay, thank you, children. We will go for the lesson. Okay, children. Now let us see one more thing. When light travels from denser to rarer, when it goes from denser to rarer, what will happen? Let us see. Okay, there is two media. Like this one, interface is there. Interface, let us consider it is a interface. Okay? What is the interface? The separation, the line separating the two media. Okay? Right? Now, let us consider it's about water. Okay? In physics, everything is going to happen in the board. Don't consider it is a board now. Now we are in water. So, it's denser medium. Denser medium. Now it's about rarer medium. Because it is air. It is water. You know the refractive index of air and water also. With refractive index also we can identify, we can say which is denser medium, which is rarer medium. But what I am going to say here, the light is travelling from denser to rarer. Denser to rarer. The light is moving like this, denser to rarer. What about this one? Point of incidence. So from this point of incidence, what will we construct? Very good. A normal can be constructed. It's about normal. What do you call this one now? Angle of incidence. Angle of incidence. When light travels from denser to rarer, what happened? The refracted ray. What happened to the refracted ray? The refracted ray will move or bend away from the normal. It's about the normal now. It will go away from the normal. Away from the normal. So actually it has to go like this, straight. But it's not moving. It's bending like this. It moving away from the normal. Clear? What we call this one? Angle of refraction. When light travels from denser to rarer, the refracted ray, the light bend away from the normal. Now, again I am going to increase this angle. It's about first incident angle, and I am increasing some angle here. One more ray like this. Then what happened? Of course, we will do one thing. I will make this one also yellow color. Okay? So, for yellow, this is one. And for this, angle of incidence is increased. So again what happened? It will move away. Again it will bend. Like this. Now, again I am going to increase. Still I am going to increase the angle of incidence. Like this. I am going to increase. White one with white chalk. It is about angle of incidence. Now for this angle of incidence, again it will bend. After bending, this refracted ray is grazes with interface or coincide with interface. Look at here carefully. For when light moving from denser to rarer, the light bend or move away from the normal. So for this yellow, some angle of refraction. For this orange, some angle of refraction. For this white, for this light, for this incident ray, the refracted ray is grazes with interface. So that this white ray, here some angle of incidence is there now. This angle of incidence, where the refracted ray grazes with interface, this incident angle is called as critical angle. What do you call that? Critical angle. Clear? Let us see what is critical angle here. Critical angle means, what is that? The angle of incidence. So simple, it is an angle of incidence. So don't think otherwise. Critical angle is nothing but it is an angle of incidence. For whom? At which the light traveling from denser to rarer is moving and grazes the interface. Which one? The refracted ray. It is about the refracted ray. When it is moving from denser to rarer, it grazes. The refracted ray grazes. Okay. For this incident angle is called as critical angle. Here very important half-mark question is that is what is the angle of refraction for a critical angle? For a critical angle, what he is going to ask? Angle of refraction. What is happening to this ray? Is grazes with interface. What is it by angle of refraction? The angle between the normal and refracted. It is about normal and it is refracted. What is the angle here? Very good, 90 degrees. So, for a critical angle, the angle of refraction is about 90 degrees. For a critical angle, the angle of refraction is 90 degrees. Or if the angle of refraction is 90 when the light is moving from denser to rarer, then the particular angle is called as critical angle. Have understood, children? Very important. For a critical angle, what is the angle of refraction? 90 degrees. If the angle of refraction is 90 degrees, what about what we call the angle of incidence? Critical angle. Okay. So when it is going to happen? Only when the light travels from denser to rarer. Don't forget about that. Okay, it's going to happen only when the light travels from where to where? Denser to rarer. Why not from rarer to denser? I will explain you about that one also. Have you understood what is critical angle now? What is critical angle? It is an angle of incidence. For whom? Which the light traveling from denser to rarer, and the refracted ray grazes with whom? Interface. It has to gauges or coincide with the interface. Then that particular incident angle is called, this incident angle is called white one. Okay, what do you call that? Critical angle. So for this, what I am going to do first, with some angle, gradually I am increasing the angle. When it's going to gauges, that particular angle is going to be considered as what do you call it? Critical angle. For that, refract angle is about 90 degrees. Have understood? Right. Now, we will see very important concept which is behind different things, different applications are there. That's about TIR, total internal reflection. Total internal reflection, which generally called as TIR, total internal reflection. Don't forget, whenever the reflection takes place, some amount of light can be absorbed by the reflected surface. When you focus the light towards a mirror, maybe 3%, 4%, 5% of the light can be captured by the particular medium, reflecting surface. Then the remaining energy, nothing but light, is going to be reflected with the common criteria. But here, no more absorption in the case of TIR, total 10% of the light whatever producing, the same amount is going to be reflected. Okay, right. Now, how it is going to happen? First, what do you call this? Interface. It's about the interface. Interface is nothing but differentiating point of two medium. One is about denser medium and the one is about rare medium. I am going to take denser medium here, maybe the water, like this. Here, denser medium is there. What do you call this one? Interface. It's about denser medium, it's about rarer medium. Now, I am sending the light from where? Denser to rarer. Denser to rarer. Like this. What do you call that one? Point of incidence. From this point of incidence, normal. Okay. What do you call this one? Angle of incidence. For this, what happened? It will bend. It will bend like this. Because it is going from denser to rarer. Now, I am sending one more incident ray like this. For this incidence angle, for this one, for this, about green color now, for this, the light is not entering into the other medium. It gauges with interface. What do you call this angle now? Is critical angle. What do you call that? Critical angle. If again I am going to increase the light angle, here incident angle, here, like this. So it is about angle of incidence. This is also angle of incidence. This is also angle of incidence. But here this angle of incidence is more than critical angle. For a critical angle, what is happening? The refracted ray is grazing with interface. For a critical angle, this one green, it grazes. Now, what about this white? This incident angle is more than critical angle. Means angle of incidence is greater than critical angle. Identify the condition here. Okay, if angle of incidence is more than the critical angle, this green is about angle of incidence. Sorry, angle of critical angle. Now this angle of incidence is more than the critical angle. Then what happened? It does not enter into the rarer medium or it does not grazes with this one. It will bend into the same medium. It will enter into the same medium. So that it is called as total internal reflection. Internal reflection. Because the same medium is traveling again to the same medium. Now the light entering into the same medium. When it is going to happen? What is the condition? If the angle of incidence is more than the critical angle. What is critical angle? If the refracted angle is 90 degree, then this particular incident angle is not critical angle. If the angle of incidence is more than the critical angle, then the light does not enter into the rarer medium. Again it will enter into the denser medium. Then total internal reflection takes place. Here there is no wastage of energy. Total entire energy is going to be captured and converted into reflection. Okay? In other cases, the plane surfaces, it may be the chances of absorbing some amount of energy. It is about total internal reflection. Don't forget one thing, TIR, total internal reflection takes place when the light travels from denser to rarer, but not rarer to denser. Applications of TIR is there, we will see that one also, but before that, the question may be asked like this. Two students are there, student X and Y. Student X said that TIR takes place when light travels from rarer to denser. Our student Y said that TIR can take place when light travels from denser to rarer. Whom do you support? Why? That is the question. Who do you support? Obviously student Y, because TIR takes place when it moves from denser to rarer, but not rarer to denser. Why? Let us see that one also. Let us consider maybe interfields and one medium to another medium. It may be the denser medium and rarer medium. Now I am sending one light ray like this. Incident from rarer to denser. It's about the point of incidence. When point of incident is there, from that we can construct a normal. When light travels from rarer to denser, then what happened now? It will bend towards the normal. What is meant by TIR? It does not enter into the other medium. It should enter the same medium, no? Means it should move away from the normal. It has to move away from the normal, no? If it move away from the normal, there are only chances to move in this medium. But what is happening? When it moves from rarer to denser, it is going towards the normal. If it has to move, or TIR is going to take place, it should move away from the normal. But it's not going to happen in the case of rarer to denser. So student X, what student X is assuming is wrong, because when light travels from rarer to denser, it doesn't move away from the normal, it is going towards the normal, then there is no chance of grazing with the interface, or there is no chance of moving the same medium. Okay, so when light travels from rarer to denser, there is no execution of TIR. If total internal reflection has to take place, certainly it has to move from where to where? Denser to rarer. Okay. And this applications of TIR, one important thing is about the brilliance of diamond. The brilliance of diamond is because of TIR of particular diamond. Because diamond is having the more refractive index of 2.42 is given in our textbook. Of course, different refractive indexes will be there. It is the average one. Each and every diamond is having their own refractive index. And you know one more thing, temple city of Tirupati, the Garuda is very famous during Brahmotsavas. There, one diamond is being to wear in the particular case. We call it as Pachala, we call that. One blue and greenish blue diamond is there, whose refractive index is about 2.44. Whose refractive index is there. It has the capacity to produce some million electric volts of energy because of its total internal reflection. Very powerful. Okay, that's the reason for every we call full moon day, it's going to happen, because whenever they fall on that, it will radiate the energy. Very powerful energy is there. Okay, let it be. So now carbon is the average one is about 2.42. The diamond refractive index is 2.42 and the critical angle is about 24 degree. Critical angle is 24 degree. These are the two regions why diamond is very precious gem. It is having the TIR. What is the critical angle? Just 24 degree. Okay, and what is the refractive index? 2.42. Now, with this critical angle and this one, how we can identify the relation of refractive index? So there is a law, that is refractive index commonly represented with n, can be given by this relation, n equal to 1 by sine c. N equal to 1 by sine c. Okay, based on this, you can identify how you can find the refractive index of particular substance. What is the relation now? N equal to 1 by sine c. N equal to 1 by sine c. For example, they given like this. If the critical angle is about 60 degree, if the critical angle is about 60 degree, what is its refractive index with respect to given medium? Okay. Simply substitute n equal to 1 by sine 60. N equal to 1 by sine 60 is about root 3 by 2. Put 3 by 2. Now n equal to reciprocal 2 by root 3. So like that, whatever the angles are going to be given, the spectrum we can find. What about sin 90? If the critical angle is 90, what happened? Already I gave an example to you. There are two conditions. When light travels from one medium to another medium, there is no bending. When it passes through the normal, or both are having the same refractive index. What I am saying here? Sin 90. So incident angle is about 90 degrees. It is a normal, no? So what happens? It will go like this. So 1 by 1. Sin 90 is about 1. 1 by 1 means get cancelled. You will get 1 only. Then refractive index means it is not moving from one medium to another medium. It is moving on the interface. On the interface. Of course, such questions may not be asked. Just identify that. Clear? Right. In the coming class, we will see the applications of TIR and what is barrages and thing. Of course, 2 more classes left to complete this. Okay, children, have understood what we discussed today about critical angle, Snell's law, and TIR, and what is the relation between refractive index and critical angle, and small problems, numericals also. Okay, children, I hope you understood. Good luck.